Hi friends, welcome back to Codelligent. In our Python series, till now we have seen three types of collections. Those are lists, tuples and dictionaries. In this video, we will be seeing the last type of collection, which is set. So let's get started. A set is a mutable collection. You can add or remove items from this collection, but you cannot change the items. So the notation is again with curly braces similar to dictionary, but it's not a key value pair. It's just a set of values similar to lists or tuples. But the specialty of set is, first thing, it will not allow duplicate values in the complete collection. If you are trying to enter same value again and again, it will consider it only once, and it is an unordered collection. That means the order in which the items are stored in this collection is not fixed, so you cannot access them with the indexing method. But to work with these sets, we have a lot of inbuilt methods available like add, remove, clear, copy, etc. And if you remember how we used to use set in our mathematical class in our schools, and we used to do union, intersection, differences, all those activities on sets, the similar thing which we can do on this collection as well. So you have inbuilt methods provided for that, like union, intersection, difference, is subset, is superset. So we will see all those things in detail with the help of a code. Now we are in our Visual Studio Code and I have created an empty file, set.py. So let's create some sets and see what we can do with that. So I'll create a set called set1 and I'll use curly braces and I will say apple, I'll say banana, and one more item, maybe mango. So now this makes one set. If you try to print the type of this, so I'll say print of type of set1, and if I try to execute this, you can see it's a set type. And if you just try to print the set, let's execute this, and you can see this is the collection which is existing. So as we said, duplicates are not allowed. So that means if I try to add one more apple here, and if you try to print this collection, you can see mango, apple and banana. So the apple exists only once. And one more thing which you notice, even though we added apple, banana, mango and then apple, and if this is repeating, ideally it will be omitted. But if you see the order here, it is mango, apple, banana, which is not like how we have created, it is jumbled. So that is the one point which we discussed just now, that it is an unordered list. So the order in which it comes is not mandatory that it will be the way we have created. And it's not that we can use only string type, we can use numbers, we can use booleans, etc. All these things are possible. So let me make it 10. True. So now if I print this, you can see this is the collection. But one thing which you need to know is true is equal to 1 and false is equal to 0 as per the set. So that means if you have 10 true, apart from this you have a number 1 and you have false and you have number 0 as well. But when you see the collection, you can see false, true and the 3 string type and the 10. The 1 and 0 has been omitted because 1 is considered to be equal to true and 0 is considered to be equal to false, and set will simply ignore them because they are duplicate. Now, as I said, it is not having any order, so that's why we cannot access any index base. So that means like how we were using on lists, we cannot use like maybe set of 3. So this thing, if you try to access, you will get an error, type error, set object is not subscriptable. So this is not possible on set. Only way you can access set is through iterating that. You can use for loop to go through this particular set and extract one by one. You can even check items whether exist in this by using an if apple in set1 print yes. So like this you can check whether so and so item exists in the set or not. So if you execute this, you can see yes is printed. So you can use this in, not in, all those keywords on set as well, but you cannot use the indexing based access. Now what if you want to add new items? So let me print this particular set, so that is set1. Now after this I will say set1 dot, you have a method called add, and in this you can say maybe xyz. So now after this I will try to print the set again, and let's execute this. You can see xyz has been added. So just forget about the ordering because it can come in any order. You don't have to bother about that because it's an unordered collection, but you just have to see whether the item has got added somewhere in the collection or not. Similar to that, you have a remove method as well. So set1 dot, you can see remove, and you can pass any value into this. So for example, if I say true, sorry, not the string one, but the actual Boolean one. So now if you execute, before executing, maybe I have to print this set1. Yeah. So now if I execute this, now you can see true has been removed from this collection. But what if I try to remove something which doesn't exist? So for example, if I say ABC, so this doesn't exist in this. So let's see what happens. So now you get a key error wherein it throws an error because ABC doesn't exist in this particular set, and you will get an exception. There might be scenarios where you want to just remove particular item and you're not bothered whether it exists or not. Like you just want to remove it if it exists. If it doesn't exist, just ignore it. So for that also you have another method called discard. So instead of using remove, if I say set1 dot discard and I pass ABC, it will do the same thing. If the item exists in the collection, it will remove it. But the difference is if it doesn't exist in the collection, it will just ignore it. So now if I execute this, now you see it doesn't throw any error. Whereas if you pass something like we have passed before true, which exists in that, and now if you execute, you can see true has been removed. So that is a slight difference between remove and discard. Both of them remove the item from the collection, but remove will throw an exception if the item doesn't exist in the collection. Discard will not throw any exception if it doesn't exist in the collection. Now we have some other methods to change the existing set. So let me remove these and let me remove this as well. So now imagine you have one more set, so which is like 1, 2, 3. So something like this. So now I have set 1 and now I have set 2, two sets. I have a method called set1 dot update where you can pass another set, and what this will do is it will update the set1 by adding all the elements of set2 into it. So just let's see what happens to set1 after this. So let me print set1, and when we execute, now you see set1 is a combination of both these set, and this is not only for a set. Imagine if you have a list. So now list1, and I'll change this to square brackets so that it becomes a list, and I will change this to list1. Now if I clear this and execute, now you can see it happens the same thing. So update method will take a set, it can take a list, it can take a dictionary, it can take a tuple. So any iterable object you can pass through this update and it will add them into the set. So these are the some of the functions which are already available for dealing with set. And apart from these, you have the standard set related functionalities like union, intersection, differences and all. So we will see that with an example. So imagine you have set 1 and I will create one more set 2. So maybe like Microsoft, Apple, Google. So these are the three companies, these are the three fruits. Now, what if I say set1 dot union of set2? So if you remember your maths class, when we do a union, it will just combine these two sets and give another set wherein the common things are not repeated. So I'll just execute this. Now you can see it is a new set which contains items from both the sets, but you can see Apple is existing only once, it is not repeated. So that is how union works. Whereas if I say print set1 dot intersection of set2, now in this case the intersection works is like between these two sets, whatever is the common element, only that it will extract and create a new set. So I'll remove this, I'll execute. Now you can see in both the sets only common item is Apple. So because of which you can see here Apple is the only item in the new set. Similar to this, you have one more method that is nothing but set1 dot difference of set2. So in this case it will take set1 and it will see what are the different items of set1 when compared to set2. So now if I execute this, you can see in set1 apple, banana and mango were the elements. Apple exists in set2, so it will remove that, and banana and mango doesn't exist here, so it will retain that and it will create a new set. So union and intersection, when you do interchange between set1 or set2, it doesn't matter, but when it comes to difference, it will make a difference if you say set1 difference set2 or set2 difference set1. So if you see like this, so now you can notice here set1 dot difference of set2 and set2 dot difference of set1, and the output will vary in both these conditions. So in this, set1 will be taken first and it will remove all the items which are existing in set2 from set1, and remaining will be returned as a new set. Whereas when we say set2 dot difference set1, it will take set2 and all the items which are existing in set1 will be removed and only the non-common items of set2 will be returned as a new set. So one thing which you need to keep in mind is whenever we are using any of these functions, that is union, intersections, difference, it is not updating any of these sets. It's not updating set1, neither it is updating set2, whereas it is returning a new set, and it is always the output is a new set which is given. Apart from this, we have two more commonly used methods. So for that, I'll just simplify this particular set. So for example, if you have set A, B and C, maybe 3 items, and in set 2 I have like F, E, D, C, B and A. So now you have set 1 with ABC, set 2 you have A, B, C, D, E, F. So I could have written in the same order, but I just wanted to reverse the order so that since the set is not bothered about the order, so I just wanted to keep it a little different. So that's why I kept it in a reverse order. So now you have a method called subset, so wherein you can check whether one set is a subset of another set. So if I say set1 dot is subset of set2. So how we are pronouncing, it's the same functionality. We are checking whether set1 is a subset of set2. If we execute this, it gives true because set1 has ABC and set2 is a bigger collection which has all these items. So set1 ideally is a subset of set2. So it will return true. Whereas if you say set2 is subset of set1, then it will say false. No, it is not. And similarly, you have another way of asking whether set2 is a superset of set1. So now in this case, you can change is subset to is superset. So now since set1 is a smaller one and all the items exist in set2, set2 becomes a superset and set1 becomes a subset. So now for this, it should give true. So in this case, this is a subset and this is a superset. So hope all the concepts which we discussed in this video related to set is clear. And with this, we will be ending our collections series as well in Python. So till now we have seen 4 types of collections, that is list, tuples, dictionaries and sets. So with this, I hope you now understand in which scenario you'll be using what kind of collection and what are the existing methods and functionalities provided by Python to deal with these collections. Thank you.